Good afternoon. I'd like to thank the Manatee Fort Pierce Observation Education Center for having me here today. I am Dr. Beth Brady. I'm a postdoctoral research fellow at Moat Marine Laboratory in Sarasota, where I study manatees. And the research I'm going to be talking about today is manatee vocalizations. But you were asking, how did I get my start? Well, I actually grew up in Pennsylvania, right, and it's landlocked, and I always wanted to be a marine biologist. And then I started taking those chemistries and physics, and I was like, I can't do this. I don't get it. It's just not for me. So I gave it up and decided I was going to become a nurse. So I went through 2 years of nursing school, and I swear that was one of the hardest things I ever had to do. And I thought, you know what, if I can make it through that, I can do anything. So I went back to school, got my bachelor's degree in Pennsylvania, and I was like, well, you can't do much marine biology in Pennsylvania. So I moved to Florida. I went to Nova Southeastern University, where I got my master's degree, and I was like, well, that's just not enough for me. So then I went to Florida Atlantic University, where I got my PhD. So I spent 7 years doing my PhD work. Right? It's a long time studying manatees and manatee vocalization. And a lot of the colleagues you see here, I actually interned with Florida Fish and Wildlife. That's how I first got my first love of manatees. I spent 9 months with them in their photo ID department, where I first learned that manatees make sounds, but there really wasn't a lot of literature about manatee vocalizations. So that's why I focused my research on what does the manatee say. And not only have I done research in Florida, I've looked at manatee vocalizations from all over the world. So let's start talking about manatee vocalizations. So a lot of animals communicate to solve problems in their environment. And although there are multiple modalities animals can use to communicate with other animals, acoustics can be the most important. So imagine if you're in a dark, turbid environment, it's really hard to see other animals, so acoustics can be really important. So one of the fundamental questions researchers like to ask is, well, how many sounds do they make, and how do they use them? So when we're trying to figure out a vocal repertoire, or how many sounds an animal would make, we look at whether or not they live in groups. So imagine an elephant, right? Elephants, they live in groups, right? They make between 8 to 15 call types, depending on the author, and they're used to maintain group cohesion, for mating, and for identification, right? Meerkats are fascinating. They have 13 different call types, just depending on the type of predator. So imagine one call type for one type of predator. 13 different types. 13. Then you have the rhino. Rhinos really don't have a lot of predators. They make 3 call types, right? On predation, they don't live in groups. So it starts to see that animals will make different sounds depending on whether or not they live in groups or not. And when we talk about sounds, we talk about discrete or graded. So what does that mean? So discrete. If you look at this call type right here and just see that call type over and over and over, it doesn't really change, right? It looks the same no matter how you look at it. This whole spectrogram, this is what a spectrogram is, it's a visual representation of sound. This is what we call discrete. So all these calls were made from one animal. And this one animal, as you approach the food source, its vocalization changed from this to something really noisy, right? So does that mean something different than this? Possibly, right? So in animals like the rhino, who have a really small repertoire, it just means they might have more vocal flexibility. So I want you to think of it this way. Do you guys have a dog or a cat?
Yeah.
I got both, right? Okay. So you know by the way your dog barks or your cat meows, it's still a dog or a bark, right? But they change it slightly differently. And you know whether or not they want to go out, they want food, they want to play. That's those graded call types. Just one sound, but it changes really slightly depending on what the animal wants or what the animal's engaged in. So when you think about this, what about manatees? What would their vocalizations look like? So let's talk about a manatee lifestyle, right? They tend to be semi-social, meaning you can see them in groups, but these groups are usually short-lived, right? A couple hours to a couple of days at most. Do manatees have predators?
Yeah.
A little bit, right? Not really though. Sharks and alligators are really not enough that they would have an alarm call like a meerkat would. So, and they're most common bond is mother and calf, right? That's the upper right. So they stay together for 1.5 to 2 years. What about their food source? Do they have to hunt for prey? No, their food source is stationary, right? So there might not be a lot of competition for food. So this leads us to believe that manatees would not have this very elaborate vocal repertoire. Let's look at their brain. So why would acoustics be important to their vocalization be important to manatees? So, oops. I'll wait for no worries. No worries. So if you look at their brain, their auditory region is huge, right? Visual cortex up at the top, rather small. So manatees are normally in very turbid or cloudy environments, right? So vision isn't really going to be a great use to them. Auditory region, huge. So this is telling me vocalizations are important to manatees. The other important sense is their somatic sense, meaning their sense of touch. They have bristles on their hairs and on their backs, and they think these help detect changes in temperatures, and tides, and maybe even other animals and potentially their food source. So how do they produce sounds? So this literature was just done not too long ago by one of my fabulous colleagues. She looked at them, she put a hydrophone on the throat and on the nose, right? And what she found was the sound was originating coming from the throat. But why would she put it on the nose? So think about it this way. When you make a sound, when you vocalize, it comes out from your vocal folds, resonates up in here in your nasal cavities, and comes out through your mouth, right? Same thing with a manatee. Sometimes when manatees are making sounds, the nasal area kind of moves around a little bit. That's how we know which individuals sometimes are making a sound. So what do we know about manatee vocalizations thus far? So this is a spectrogram again for a visual representation of sound. We know the fundamental frequency or the pitch, right? What your voice sounds like is the pitch between 2 to 5 kilohertz, surrounding this white box right here. Dominant frequency band, or where the most energy is in the call. It's usually the first harmonic above the fundamental. All right, you guys are welcome to sit down if you like. Most calls contain this harmonic structure. It's like you play your guitar and the ring, and all those sounds that come off out of the harmonics. Most calls have frequency modulation, which means they're not flat. They move up and down like that. So this is kind of an example. So when we think about manatee vocalizations, you know they make these tonal sounds right to the left. They make these modulated sounds right there, and those noisy sounds on the end. But do they mean something different? So that's what I set to find out. And what about cows and calves, right? Are their calls different from one another? So imagine, your voice changes as you age, right? From a little kid to an adult. What about for a manatee? And we know there's more than one type of manatee, right? You have the West Indian manatee, which is the Antillean, and in Florida, the Amazonia, which is a freshwater manatee species, African manatee, and then the dugong, which of course we won't get into today. But are their vocalizations different across species? So I want you to think about it this way. We're in the United States. I bet you can tell the difference between somebody who lives here and someone from England, right? Different. What about even within the United States? What about someone from New York and someone from the Deep South? So even within the United States, we have some variation in the way we talk. What about manatees, right? So this leads me to my questions. What is the manatee vocal repertoire, right? Are their calls associated with behavior? How do they use them? Do their calls change with age? Are the calls different between species? Oh, yeah, first we're going to focus on is the manatee vocal repertoire. So how do I do my recording, right? I use an underwater microphone or a hydrophone, like hydro means water. This is what my setup kind of looks like. So over there to the right, I'll put all my electronic stuff in a pelican case, attached to the hydrophone. Sometimes I'll put it in the buoy, and I'll set it in the water. So the first part I did was looking at that vocal repertoire, and I looked at 3 locations. I looked at Portoswino Park. This is on the west coast of Florida. It's an area where manatees come to drink fresh water. Crystal River, you're probably very familiar with that. It's on the west coast. It's also fresh water. It's a wintertime refuge for manatees. They don't tolerate temperatures lower than 70 degrees really well. So during the winter months, they go to low water. And the other place I did was in Blue Springs. That's on the east coast of Florida. It's a little bit further north of here. Another warm winter refuge where manatees will go to stay warm during winter months. So I put the hiding phone in each of these locations, had it in for about 24 to 48 hours in each location. And so just to give you a general idea of how many manatees were there, this area had about 5 to 12, Crystal River had about 50, and then Blue Springs had about 120. So I got a lot of manatee vocalizations, thousands, tens of thousands in about 72 hours. So I did some fancy statistics, right? And I determined that manatees make 5 different call types. So I'm going to play this for you really quickly, so hopefully you can hear what a manatee sounds like. Oops. There it is. There. You guys hear that? Yeah, that's not very loud. Let me see if I can.
Sounded like a cockroach.
Yeah, it's like a that sound. It's like a high-pitched mouse. We can play that again. I'm sorry, it's really noisy here. So anyway, to make a long story short, I determined that there were 5 call types. The squeak, which is talked about a lot in the literature when we talk about between species. The hill-shaped high squeak call is going to be really important in the next coming minutes. Noisy sounding squeal, a squeak squeal, which is a combination of this call and chirp. Well, that's great. I determine what their vocal repertoire, but that doesn't necessarily mean that it's important to the animal. So the next step of the thing, one more thing I forgot. We also looked at ultrasonic vocalizations, meaning manatees are producing frequencies that go higher than humans can hear. So this is a study we did, showing they go way up into the frequency spectrum, above 40 kilohertz. It's really loud, right? It's really crazy that manatees speak in that high of a range. Anyway, so the next thing we wanted to look at were other calls associated with behavior. We did just publish this back in 2020. So how did I do this? So again, I went back to my sites. I went to Portosweno Park, where the manatees come in on a regular basis for their fresh water. I went to Crystal River. Now here was a little bit different. So here they actually did health assessments every winter. So they would actually capture individual manatees and do just like a health checkup on them. I went to Singer Island, and that was an area where you have forage, natural forage. And Harbor Branch, which is not too far away from here in Fort Pierce, another passive thermal refuge. So this temperature stayed just a little bit warmer than what it is in the Indian River Lagoon. So I put hydrophones out there, and I looked at a couple of different behaviors. I also looked at a number of animals. So you have to know how many animals are engaged in behavior, right? So if you have 4 animals, and one animal's resting, and the rest are doing something else, then I can't use it as resting. That makes sense, right? So you count the number of animals, and then I wanted to know, was there a difference when calves were present? So how do you know you have a calf? Sometimes they're visibly smaller, like this guy is here, and they'll travel what we call cow-calf position. The calf stays right behind the mom on the flipper. Sometimes, if you're lucky to see over here, we have observations of nursing, right? Sometimes you get those larger calves, and it's hard to tell the difference. So I looked at a couple different behaviors. Manatees spend a lot of time resting. So they'll sit at the surface, right? When it's nice and warm, they'll sit and bask at the surface. Sometimes they'll do what we call bottom resting, which means they'll sit down there for 6 to 7 minutes. They'll come up, take a breath, and kind of sink back down to where they were. We have feeding, where manatees will chew on debris at the surface. Sometimes they'll go down and they'll dig in there and they'll leave mud trails. And then you'll see them come up a little bit more frequently. Stress. These are the animals that we captured at Crystal River. They're definitely stressed. You're pulling them in. And then cavorting, which is otherwise known as playing, or just animals that are physically interacting with one another. There's a little video of what they were doing when they were cavorting. A lot of splashing and a lot of physical activity. Fun to watch. So I also wanted to look at those graded call types, right? So remember when I was talking about your cat or your dog, how they make those subtle changes? Well, we actually measure those changes in science to see if they're different. So some of the variables I looked at was duration. How long was the call? How modulated modulated was the call. Remember, up and down. And we're thinking that animals that are more active, right, or would be like stressed or cavorting, they'd be more modulated, right? We're also looking at entropy, or how much noise is in the call. And that's even in that spectrogram on the end, how much noise. So sometimes animals, when they make noisy calls, they can be more excited as well. So we also wanted to measure those factors as well. So what did we find? So out of those 5 call types I found, they primarily used 3, right? They used this hill-shaped call, they used that squeak, and those noisy squeals. So that's pretty little, right? Imagine all these call types, which means they really use 3. But they definitely alter the structure of the call, like your dog or your cat, depending on the behavior that they're engaged in. So this is resting, right? Sometimes they rest like that. You get really comfortable. So what do you guys think? So they found a lot of squeaks in their calls, but do you think they were flat, or do you think they were more modulated? These were actually quite flat. Remember, they're a low state of arousal. They're just kind of resting. They're not really doing a whole much. So they're really flat. Here's a manatee. Let's see if it'll play. Oops. Go back there so we can get the video going. Yeah. Going. There we go. So this is a manatee feeding off of some algae on the wall. That's how close I was able to get to them. I'm going to try and stay here for a second to play some chewing sounds for you. Yeah, you're not going to be able to hear that. I'm sorry. Sorry about that, but it sounds like a lot of crunching. So again, these sounds were quite tonal and flat, right? Cavorting. Give away the course. See if we can play this video for you of manatees playing. There you go. It's about 8 animals playing. Stay back here until that stops. So what do you guys think? Do you think these calls were more modulated, or do you think they were more flat and tonal? These were actually a lot more modulated, and there were a lot more of those noisy calls in there. Why these noisy calls? So noisy calls could actually be an animal in a state of aggression. Like some of these calls we see, those like, imagine your dog, that roughness in his voice, he's growling at something he doesn't like. But also can indicate, like we saw in the very beginning, you're just really excited, right? So imagine like that animal is approaching a food source and the sound got more noisy. Same thing here, because we don't really know manatees to be aggressive. However, when they are cavorting, they're mimicking mating behavior. They do something really similar when they're mating. So maybe it potentially could be aggression. Still have yet to find out. Last but not least, stress. Captured 120 animals over 8 years. So do you think this was more modulated or more flat? Yeah, exactly. Modulated, exactly. And a lot longer in duration. So imagine you're in a horror picture show, right? Ah! Exactly. So stress sounds a lot longer and a lot more modulated. So this is telling us that manatees, again, like other animals who don't live in groups, few call types, and they alter the structure of the call depending on the behavior they're engaged in. Do calls change with age? Yes, this was just published last week. What about this one? So remember those hill-shaped calls that I was telling you about? We found that these are actually from younger calves. So what I'm showing you here in this video, this picture, each one of these is from an individual calf, each one of these spectrograms, and the numbers represent the length of the animal. So for the Florida species and the Antillean manatee species, we found a lot of similarities. So as the calf is young, it creates this hill-shaped call, and as it gets older, it becomes more and more flat to become that adult type of squeak. How interesting is that? They can live up to 40 years of age in the wild approximately. The one that we know of lived the most was Snooty, who was 69 years old until he unfortunately passed away. So yeah, interesting, right? So they do change their calls as they age. This is really important, right? So in Florida, we see manatees rather readily. We can go out here, or we can go to an aggregation site, or like Tico Power Plant, see thousands of manatees. Not the same story in Mexico and Amazon. They're very cryptic. They used to be hunted. In some places they're still hunted, and you don't get these large aggregations. It's warmer there. They don't have to aggregate like Florida manatees do. So the important thing of this work is now you can put a hydrophone in the water. Not only will you know if manatees are there, but you'll know if they'll have a younger calf there, which is really important for population. Are they different between species? So again, we have these different populations of manatees. You have the West Indian species from Antillean in Florida, Antilleans in Cuba, Belize, Mexico, around that region, Amazonian manatees, like we said, the Amazon and the African manatee. So here's the Antillean manatee on the bottom, the Florida manatee on the top. Can you guys see any differences between the two? What do you see? Yeah, so they are slightly different from one another, not really. Antillean manatees tend to be just a little bit smaller. And we just are getting the reviews back on this one. So this is from Belize, Panama, and Florida. And yeah, we're finding they are slightly different in each location. Just like I said, in the United States, you have differences between New York and the South. Same thing with the manatees. They're slightly different locations, just slightly different ways in the way they produce the sound. This is another one will show exactly the same thing, all different parameters that we measure. So what about the Amazonian manatee? This is a freshwater species, right? They're the smallest of the manatee species. Do you see any physical differences between these two species? What do you see? Yeah. What about its belly? You see the belly? Yes. Exactly, you're right on point. So yeah, so this is the smallest of the manatee species. So imagine a smaller animal, think of a mouse and an elephant. A mouse is probably going to be more high-pitched than an elephant, right? Same thing here, right? So Amazonian manatees tend to be higher in frequency or higher in pitch. We also notice that they make what we call notes. So this is from our last article, kind of hard to see here, but they're kind of separated, right? Why is that? It's just something that's slightly different with the Amazonian manatee. Another thing that goes along with how their vocalizations change as they age. They don't tend to see this in Amazonian manatees after a certain age. But that's how they are slightly different from the West Indian manatee population. What about those African manatees? So African manatee here on the left, Florida manatee on the right. See any differences between them? Exactly. Perfect. So the African manatee looks very similar, right? Their eyes are just slightly different and they have a slightly more deflected snout. So there's a study that we did where we put a hydrophone in this place in Cameroon, this Lake Assa Wildlife Preserve, and we just wanted to see, do African manatees make sounds? Because we really didn't know. There were really only one other study done on African manatee vocalization, if you can believe that. So yeah, 2021, the first characterization of African manatee vocalizations. And here's some African manatee vocalizations. They look exactly like Florida manatee vocalizations. So there is a lot of overlap there too. Here's the interesting thing though. Most of these vocalizations were produced at night. Any thoughts of why? So African manatees are still hunted, so they're thinking maybe at night, but the fascinating thing about this is we're doing some more research right now, and we're seeing this as a similar trend in Florida, in Belize, right? Manatees tend to vocalize more at night, but we still need some more research into why. But this is a trend that we're seeing across species, that they're vocalizing more at night. Not quite sure why. I think it might have to do with patterns potentially. Maybe they're resting during the day and feeding more at night. It's a tend pattern that we tend to see. Maybe they're just avoiding boats or humans. Not quite sure. Still needs to do more about that. And then again, like I said, we were talking about difference between the three manatee cat species, the paper we just published. And yeah, there are definite differences between the Antillean, the Florida, and the Amazonian calves. So here's your Amazonian. All the parameters are higher in frequencies, even its calves, right? You would think even the small size of the Florida manatee would be comparable to the small size of the Amazonian manatee. It doesn't matter. The Amazonian manatee is smaller across the board. They also grow a lot slower. So a Florida Antillean manatee, they go from little babies to like huge. They gain like 200 kilograms, I think, in the first year of life. They grow exponentially. Where Amazonian manatees, they stay rather small from birth. So it makes sense that their vocalizations would be higher in frequency as they grow. So some of the things we're working on now, playback experiments. If I play sounds to you, right, to the animal, I want to know, does it matter if it's male or female? Does it matter if it's a tone call or an atonal call? What does this call mean to the animal? So to do this, we did this in Mexico in dolphin discovery, a captive environment. So this was a group of female animals in this tank. So this was the other tank we tried to do it in. And so you notice there's some dolphins around there. And so this site didn't really work out well because there's a lot of dolphins. And dolphins are very fierce. So everything you see here is dolphin. So even though I might have played a sound, right, they couldn't hear it. Yeah, you can tell the difference of the vocalization, whether it's a dolphin or whether it's a manatee. However, we're going to look at some of those experiments, what happened in Mexico, to play some of the video for you to show you what we're finding so far. So it's 10 seconds before I'm playing the sound. Four, three, two, one. There's a manatee up towards that first, and he's coming right back there. So he was kind of startled by the vocalization that I played. But what we noticed more so with these animals is that usually when they would hear the sound, they would be more vocal, and they would turn and go towards the speaker. Right? So we did that, and these are a group of female manatees. We also did this at Moat. So where I work, we have two resident manatees. We have Hugh and Buffett, two male manatees. So we wanted to know, well, is it different between males and females? And this was kind of our setup here. I would sit down below. The speaker you can see is that little PVC piping down below with that blue thing there. We put some hydrophones up there. So let's see how these guys responded. I think you'll find this interesting. So this is Hugh and Buffett. Hugh is sleeping on the thing back there.
Rate sound is 2616, and rate sound Hugh is still, yeah, he's still sleeping on the shelf. He could have cared less.
Yeah, they could have cared less.
But you used to rest.
Any sound that I played to them, they didn't really care about. They didn't move, they didn't orient towards the speaker. They just continued whatever they wanted to do. However,
This was at nighttime?
this was during the day, in the morning, and in the afternoon. But the cool thing about this, but we found something really interesting. These are clicking sounds produced by manatees. Why are manatees making clicking sounds that look like dolphin echolocation clicks? right? This is fascinating to me. Now, I saw you those clicks before. Let me just go back. So, right, these are dolphin echolocation clicks. They make a lot of clicks in rapid succession, right? Not a manatee. However, why are they clicking? What would they be using this for? So again, this kind of goes back to, maybe we have some ideas, so your thoughts may go along with mine. Maybe they use it to navigate. So I always think of humans can sometimes use their tongue, make a clicking sound, and they can determine whether or not something's in a room. What about a manatee? And this is just something they actually clicked more than they vocalized. So what does that mean? Why are manatees clicking? And is it some kind of rudimentary navigational sense? We plan on doing more experiments on this to find out. This is like fascinating. Made me so excited. I was like, why are they doing this? I have no clue. So, and some of the other things I work on is anthropogenic noise impacts on manatees. So there's a lot of ecotourism. It goes around, like the Crystal River and in Mexico. And what I'm going to show you is some of those videos that we got of some of the issues that we're having in Mexico. I'll show you some of those videos. Hopefully you can see this one. So this is from the drone. And if you look to the far left, that is a resting hole. It's kind of hard to see in here, but there is a small herd of manatees. We're going to get a little bit lower. And you can see in the upper right, there's two manatees right there. Those little blobbies are manatees, right? So this is a resting hole that they go to. It has a freshwater outflow, and they'll spend a significant amount of time here. We usually see them here during the day. I do have some vocalizations from them at night. The drone is coming down a little bit further, so you can see those manatees a little bit better. Yeah, good, really good view of those animals. So that's what a happy herd of manatees looks like, right? What does it look like when there are boats there, and what are the boats doing? So in this image, you have the manatee, you see him in the middle, and 4 boats, right? It's a lot of boats. I mean, there's not even that many. Imagine 4. This is just 4 and a cow-calf pair. And how imagine they're being surrounded by noise from the boat, as well as people want to see the manatees up close and personal, right? And here is the other one. This is the cow-calf pair. This is just 2 boats. And they have the cow-calf, where you see it right in the middle there, they're surfacing. They're kind of chasing them in the middle there. And pinning them in, so it's hard for them to get away. So those are some of the things that we're working on in Mexico to look at tourism impacts on manatees. Let's go back. So last but not least, or not least yet, so the interesting thing is, elephants and manatees are in the same, they're evolutionarily related to one another. So I always find it fascinating to use elephant vocalizations up top, manatee vocalizations on the bottom, and how actually very similar they look to one another. The biggest difference is that elephants are a lot lower in pitch, right? They're about 20 hertz, which means infrasonic. Sometimes we can't hear the sounds that they make. The manatees are more around 2,000 hertz, which is something that we can hear with our ears. So elephants are adapted to living on land. If manatees made sounds that low in the water, they probably wouldn't propagate very well because they're in really shallow water environments. But it's really fascinating to look at the call types and see how actually very similar they are to one another. And I also want to talk about what you guys have done here. So this is something we're working on. The citizen scientists here have collected data of manatee presence over 20 years. That's 20 years of data going back to 1997, 98. The fascinating thing is, so every dot that you see is the number of manatees observed in a given year. Basically what we're seeing is a steady trend that didn't really increase or decrease over the past 20 years. There's a slight downward trend but not significant. Meaning this area is a really vital habitat that manatees have been using consistently for the past 20 years during winter months. Very interesting, right? Oh, the cows and calves. Oops. So yeah. The other thing we hope to work on here is look at a calf parking study. Sometimes moms will bring their calves in here and leave them here and go out and forage to feed. We really don't know a lot about that behavior, so we're also trying to do a little bit of that work here. Seeing like, what does a calf do when her mom leaves? How long do they stay here? What does a calf do? Does it sit here and rest? Does it associate with other animals? What conditions does this usually have? And that's it. That's my talk on manatee mobilization. I hope you enjoyed it, and I'm happy to take any other questions. Ooh, so we don't really know if they go, she asked if they go from the east coast to the west coast. So there is some evidence of that, but the fascinating thing is, as of late, we're finding them migrating rather long distances. So there was a manatee in Fort Lauderdale, who they found in Mexico, another one from Crystal River, who they found in Cuba, and another one from Crystal River they found in the Bahamas. So they're traveling a lot longer distances than we ever imagined. So there's even one that went up into the New England states, his name's Chessie, right? So they can travel really long distances. We're only getting an inkling of how much these populations are intermixing with one another. Yeah, so they need to come back down, and sometimes they do need to be rescued when they get up that far.
Relatively quickly when they want to, like whether
Exactly.
or do they just longer?
They usually go about 5 to 6 miles per hour, but they will have bursts of speed up to 20 miles per hour, so they can move fast when they want to. They normally don't. They go around pretty slowly, but they still swim faster, as my colleague likes to say, than Michael Phelps. They still swim faster, right? Diane Morgan always says about that.
What would attract them to New England?
What would attract them to what?
To go up to New England.
Not quite sure why I went up there. So it was, I believe it was a male, and males usually roam in search of mates. So you don't want to stay inside where your area is because you don't want to mate with your siblings, right? So males will tend to roam and roam. Not quite sure why I went that far. Maybe just get donga. I'm not quite sure why I went that far. But yeah, they will roam and go rather longer distances.
How deep of water would they go to?
So they tend to stay in relatively shallow waters where their food sources are. When they're traversing to the Bahamas and Cuba, I assume either they're staying close to the shoreline. I'm not sure how they got to the Bahamas. I really don't know. They had to traverse some kind of ocean, but they tend to stay rather shallow. Now, dugongs are their cousins. They're fascinating. They have a tail like a dolphin and a really downward facing snout. Those animals dive a lot deeper, but they have a tail that allows them to do that a little bit better. But these animals tend to stay rather close to shallow waters. Have to live. So they can live, the longest living manatee was Snooty, up to 69 years of age until he passed away. But animals and manatees in the wild, usually about anywhere about 40 years is about the average that we're seeing.
So they only have one calf at a time, or
They can have twins. It's very rare, usually about 3 to 4% of the population. Actually, I had a picture of twins. I don't know if I had it in this talk, but yeah. They do have twins occasionally, but usually one baby once about every 2 to 4 years. They usually nurse that baby for about 1.5 to 2 years until that calf goes out on its own. Thank you. You're welcome. Thank you. You were awesome.